Okay, today we're going to start with the flowchart and paragraph proofs. So far when we did the proofs, we talked about the two-column proofs, right? We read the two-column proofs, and we said that each line item had to have a specific reason or logic behind it, and we filled out the two columns, okay? So the second and third ones are the flowchart and the paragraph proofs. These are not used as widely as the two-column proofs, yet it's something you have to know, you're required to know. So let's go ahead and look at the flowchart first. A flowchart, if anybody's in coding or did programming, you have a flowchart where you start from here, and then you go yes or no, right? Yes or no, and then you go to a different item, and then yes or no, and it flows down, right? This is what a flowchart is, okay? So it's gonna follow something that looks like this, the flowchart proof is, okay? So one of these items that they're gonna throw at us to learn the flowchart proof is the theorem 2-7-1, which is on the middle of page 118, says the common segments theorem, and that is nothing more than if I have A and B and I have C and D, and what I'm saying, so the common segment theorem says that if A, B, and CD are congruent, if they're congruent, then AC and BD are congruent. So in other words, if these two are the same, if AB and CD are the same, then AC and BD are the same. So the reason why it's called the common segment theorem is because you have a common segment here that is shared in the end result. You have the common segment BC that is shared at the end, okay? So let's see, and this kind of makes sense, right? I mean, if this was, let's say that this was 3 and this was 5 and this was 3, right? It makes sense, right? Because AC would be 3 plus 5, whereas BD would be 5 plus 3. They're both 8. It makes sense. Okay? All right. So let's go ahead and now see if we can go ahead and write a flowchart proof. Okay, so let's go to example number 1. Example number 1, it shows you how to write the flowchart proof. Okay, so you have, in the first bubble, you have A, B, and C, D are congruent, and this is a what? Given, right? It's given, and it goes down that way, right? If this is given, but if this is true, that means that A, B, and C, D are the same length. Okay, and this is the definition of it, right? And then you go from here to saying, well, I'm going to go ahead and say that BC is equal to BC, which is the reflective thing, right? But also what this gives us is that it allows us to say, I'm going to add A, B, and I'm going to add BC to both sides. BC plus CD, right? So I added 2 here, a BC, added 2 here, a BC, okay? So now from here, this becomes, from here I can go, well, this means that AB plus BC, if you remember, A, B, C, D, AB plus BC, AB plus BC is AC, right? BC plus CD is BD. So BD, and then from here, I can say that since that is true, AC and BD are congruent. Okay, now I did not write all the givens or the logic here, so let's go ahead and write that. Okay, so this was a definition of the segment, right? This is the definition of the segment, right? And this is the reflexive property, right? Reflexive property. And then you come down here, and this is the what? This is the addition. So it's the substitution. We substituted here. Okay, and then from here to here, well, I'm missing a step. Oh, no, this is here. Oh, I'm using this guy over here. This guy actually goes here. Goes here. Then from here, what do we have? We have, this is the subtraction property of, so this is the definition of a segment. Again, definition of a segment. It's the same thing. It's the same thing that we use over here. Definition of segment, right? Okay. This is the reflexive, and then coming down from here was what? This is the subtraction property of a segment, right? Oh, no, of equality. Okay, so equality. So you can go ahead and subtract each one. Okay, so again, each one has a reason, and you have to follow it through. Okay, a lot of times the question they're going to give you, or the question that you're going to get, are they're going to give you the two-column proof, and you just have to go ahead and construct one of these. So you have to be able to take each separate line, okay, and then put them in order and the logic behind it. Okay, all right. So let's see if we can do, so that actually is example number 2 also. Example number 2 is the same thing. Example number 2, it says writing a flowchart proof, reading a flowchart. Also, we were reading the example 1, and example 2, we were writing it, okay? All right. So I actually did example number 2, all of it together on the same. Let's go to page 120 and page 120. We're talking about the paragraph proof. Okay, and the paragraph proof is really all you're doing is you're writing a paragraph. In other words, there is no structured 2 columns, nor is there a structured little bubbles where you have arrows going to each bubble with a logic line, okay? All right? In paragraph, you're just writing as you would write an essay. In paragraph, you're just writing, you know, what's happening and what's going on. Okay? So a paragraph proof is a style of proof that presents the steps of the proof and their matching reasons in sentences in a paragraph. Okay, although the style of proof is less formal, you still must include every step. Okay, and in order to go through this, what they're going to give us the theorem is the vertical angles theorem, 272. 272, okay. If they are vertical angles, they are congruent, right? If you have vertical angles, they are congruent. Makes sense, right? That's what the vertical angles are, right? Okay. And then you have 2-7-3. If 2 congruent angles are supplementary, so if I have 2 angles, angle 1 and angle 2, if they are supplementary, okay, and they are congruent, that means that they both have to be what? They both have to be, since they have to add to 180 because they're supplementary, right? And they're the same, they have to be 2 90-degree angles, correct? So that's the only way you're going to get 90 plus 90 is 180, right? Okay, so let's do example number 4. Example number 4, and see if we can write a paragraph proof. Okay, so example number 3 says reading a paragraph proof. Okay, use the given paragraph proof to write a 2-column proof of the vertical angles theorem. The vertical angles theorem was the first angle theorem that we talked about. Okay, so we're going to go from the paragraph proof to a two column proof, right? So let's go ahead and prepare our two columns. So let's read. It says, given that 1 and 3 are vertical angles, prove that angle 1 and angle 3 are congruent, okay? So the paragraph proof says, number 1, angle 1 and angle 3 are vertical angles, so they are formed by intersecting lines, okay? So the first thing that we're going to write is that angle 1, angle 2 are vertical angles, okay? And that was a given, right? This is given to us. So that's the first line. Angle 1 and 2 are vertical, and that's given to us, okay? All right. So it says then angle 1 and 3 are formed, so they are formed by intersecting lines. Okay, so they are formed by intersecting lines, and this is the definition of vertical angles. Okay, again, I'm just writing down, following the logic that's written in the paragraph. Okay, and then it says what? Therefore, 1 and 2 are a linear pair, and 2 and 3 are a linear pair. Okay, that means that, so therefore, 1 and 2 are a linear pair, and 2 and 3 are linear pairs. Okay, and that is a definition of a linear pair. Okay, then what? Then what we're reading along, it says, by the linear pair theorem, 1 and 2 are supplementary and 2 or 3 are supplementary. So we have 1 and angle 2 are supplementary, angle 2 and angle 3 are supplementary. And this is by the linear pair theorem. Okay. And then since we run out of room, then what we say is that there's linear pair, therefore angle 1 and angle 2, 3 are congruent, and that is due to the what? So by the congruent supplements theorem, they are the same. By the congruent supplements theorem, angle 1 and angle 3 are congruent, okay? Again, I'm not reinventing anything here. I don't even have to think that much. All I'm doing is reading the paragraph and putting it in a two-column proof. Okay, so that's that. So that's how you go about doing that. Again, you just have to read it and be able to put it into a two-column format, okay? Nothing really hard there, okay? Example number 4, use the given two-column proof to write a paragraph proof. Okay, now we're going to write a paragraph proof from the two-column proof, okay? So let's go ahead and I'm not going to write this down because it's pretty drawn out. So let's go ahead and just read through it. Example number 4, it's a two-column proof. So so this is what I would write in my paragraph, okay? Angle 1 and given that angle 1 and angle 2 are supplementary, so the angle 1 and angle 2 would add to 180 degrees by the definition of the supplementary angles. They are also congruent, so their measures are equal, okay? They have to be the same, right? By the definition of the congruent angles. Then by substitution, I can say that angle 1 plus angle 1 is equal to 180 degrees, which means that angle 1 has to be 90 degrees, okay? Because angle 1 and angle 2 are the same, that means that angle 2 also has to be 90 degrees. So they are, so by the transitive property of equality, so both are right angles by the definition, okay? Again, you're just reading through the two columns and writing it in a paragraph. Okay? So that's that. We're done with that. We're done with 2.7. So this is a little bit kind of an odd, again, a little bit not something you're used to doing, okay? And so the flow chart, again, the flow chart and the paragraph proof are the lesser cousins of the 2-column proof, yet it's the same thing. The one thing that all 3 proofs hold in common is that each action or each step has to be accompanied with the logic behind it. Okay?